All right, so let's take a look at some rational and irrational numbers. So let's look at rational numbers first. A rational number is a number that can be expressed as a fraction where both the numerator and denominator in a fraction are integers. The denominator cannot equal 0. Next, a rational number can be written as a terminating decimal, and it can be an infinite repeating decimal. So we have some examples right here of rational numbers. All right, so we have this 21 or 0.21. That line here tells us that it's repeating. All right, this 0.97, this decimal terminates or stops. We can reduce this -8/2 to -4. The square root of 9 is 3. 1/3 is 0.3333 repeating. And so we get the point here, hopefully. So with a rational number, it's either a whole number or an integer. If it is a decimal, the decimal stops. Or if it repeats the same number. All right, so let's take a look at irrational numbers. It cannot be written as a fraction. Decimals do not terminate. And it's the infinite non-repeating decimal, so it does not repeat the same number. So here are some examples of irrational numbers. All of these are irrational. So as an example, if I take the square root of 8, I would get 2.82847, and it keeps going with different numbers. So that is irrational because the decimal keeps going and it does not repeat the same number. So those are irrational numbers. Again, pi. And if I take the square root of 2/5, I get 0.6324. And the numbers are different. It keeps going. So again, irrational numbers is a continuous decimal that does not repeat the same number. All right, so let's compare rational and irrational numbers. So as you can see, rational numbers include quite a bit. It includes repeating decimals right here. It includes integers right here. It includes decimals that stop also. But irrational numbers are numbers that the decimal keeps going. It does not repeat the same number, nor does it terminate. So if you can just remember that everything else, every other real number is rational except the number that is a non-repeating decimal, meaning it does not repeat the same thing. That is irrational. All right, so let's look at this problem here. We want to determine whether the following numbers are rational or irrational. All right, so the square root of 9. The square root of 9 is 3, so that would be rational. All right. The square root of 8 is like 2.82847, and it actually keeps going, so that would be irrational. Pi is always irrational. We know that that keeps going. 22/7 is a fraction. So a rational number can be written as a fraction, so that is rational. 9.48, that is rational as well because this line here tells me that that 48 is repeating the same numbers. All right, 32/2, again, that is a fraction, so that is rational. 2.23606 ... tells me that that keeps going infinitely. It does not repeat the same number. So that is irrational. And of course, -25 is rational. It is not a decimal that does not keep going. All right, so let's analyze rational and irrational numbers by giving some examples. So the sum of two rational numbers is always rational. And some examples of that are, we could say, two rational numbers, 3 plus 5, that's 8. So all three of those numbers are rational. 3 and 5 is rational. The result is also rational as well. We could do 1/3 plus 1/2. That gives me 5/6. So all three of these numbers are rational as well. So the sum of two rational numbers is always rational. The product of two rational numbers is always rational as well. Examples: 3 times -5, that gives me -15. Another example, 0.3 times 1.7, that gives me 0.51. So all those numbers are rational. So the sum and product of any two rational numbers is always rational. All right, so let's look at these two. The sum of a rational number and an irrational number is always irrational. An example would be 4 plus the square root of 12. This 4 is rational, square root of 12 is irrational. And just to break it down a little more, we could rewrite the square root of 12 as 2 times the square root of 3. That 3 is irrational. Another one would be 2 plus pi. Because pi is irrational, doesn't matter what number you add to it, the result will still be irrational. Next, we have the product of a non-zero rational number. So it cannot be 0, but if it's a rational number that is not 0 and an irrational number, it is always irrational. An example would be 2 times square root of 5. Because the square root of 5 is irrational, the result would be irrational. Another one, 4 times pi. Because pi is irrational, if you multiply it by 4, it's still going to give you an irrational number. Alright, so we have this problem here. It says select all expressions that result in a rational number. So go ahead and pause the video and try this one on your own. Okay, so hopefully you got them correct. The only two were the first one here and the third one. All right, 49, the square root of 49 minus 16, that would just be 7 minus 4, which is 3. And for this one here, you have 10 pi minus pi times the square root of 100. So if we rewrite this, what's the square root of 100? That is 10. So we can rewrite this as 10 pi minus 10 pi. That will give me 0, which is a rational number. So just because you see pi doesn't mean that it's going to be irrational. Analyze that problem a little bit more. All right, so the last one I would like for you to try, it says Thomas argues that the square root of 27 over the square root of 3 is rational. Mateo argues that the quotient between 27 and 3, or the square root of it, is irrational. Prove who is right. Make sure you justify your answer. So go ahead and just pause this video and try this problem on your own. Alright, so hopefully you got this problem correct. Thomas is correct because the expression simplifies to a rational number, that is 3. When you divide 27 by 3, you get 9, and the square root of 9 is 3. So that is a rational number. Thomas is correct. Alright, so we've reached the end of our lesson. I want to thank you for learning with me. Some related videos are listed below. If you like, please like, comment, share, and subscribe. And again, I want to thank you for learning with me.